The combustion of fossil fuels enables us to enjoy the lifestyles we have today. But did you know that combustion releases chemicals into the environment that are harmful? This lesson is on acid deposition and the products of combustion reactions. So, combustion reactions, such as cellular respiration and the combustion of fossil fuels, are very useful because they produce energy, but they also produce emissions that can be harmful. So, collisions between the methane and oxygen molecules will form new molecules. And if a hydrocarbon combusts, water vapor and carbon dioxide are formed, and these are waste products. So here we have methane and oxygen, and they can form carbon dioxide and water, and some other combustion reactions like propane and oxygen form carbon dioxide and water, and ethanol and oxygen form carbon dioxide and water. Now, these aren't balanced chemical equations that are shown down there. So, different oxides of carbon occur when we burn carbon compounds. So this could be anything with biomass or hydrocarbons. And so we produce carbon dioxide, so cellular respiration as well as volcanic eruptions. Now, carbon dioxide is important in the carbon cycle for the production of glucose in photosynthesis, and it also, as a greenhouse gas, is necessary to keep the earth warm enough for life to survive, but it also contributes to climate change. So here's some examples of the carbon cycle where carbon dioxide will go out of the atmosphere during photosynthesis and back into the atmosphere through decomposition or cellular respiration. We can also store carbon long term in the ocean, in carbon sediments, as well as in coal and oil, and in the biomass of trees. So this diagram of the greenhouse effect shows how lots of the sun's energy is both reflected by the atmosphere and absorbed by the atmosphere. So some of the infrared radiation is absorbed and re-emitted by the greenhouse gas molecules, and this warms up the Earth's surface and the troposphere. And this is important so that we don't get freezing cold at night when the sun's not blowing. So the greenhouse gases do play an important role in our atmosphere. However, the increased amount of carbon dioxide in the atmosphere has increased this effect, which is leading to an overall warming of the Earth's average temperature. The ozone layer is a layer up in the stratosphere that helps to absorb harmful UVC rays from the sun's solar energy. Now, when we have ozone molecules that come in contact with a free chlorine ion, they will break apart and form oxygen molecules. Now, this will damage the ozone layer, which makes it more likely that harmful UV radiation can get through the stratosphere and come strike down organisms on Earth. And this can cause mutations and cancers. So oxygen molecules can be photolyzed, which yields two oxygen atoms that are slow moving. So ozone and oxygen atoms are continuously being interconnected as solar UV breaks down ozone. So the way that the ozone breaks down or absorbs UVC is the UVC will break apart those ozone molecules, turn them into oxygen molecules, which will then turn back into ozone molecules. So carbon monoxide is also produced during combustion, and this occurs when the quantity of oxygen is limited. So we're not able to make CO2, so we make CO. It can be caused by vehicle exhaust, furnaces that are in poor condition, and there's a natural concentration of carbon monoxide in air. It's around 0.2 parts per million. Now, unfortunately, carbon monoxide will bond to hemoglobin more easily than oxygen. So if there's too much carbon monoxide in your environment, your body cells aren't going to be getting enough oxygen because hemoglobin will carry around carbon monoxide in your blood instead, which is why it's important to have a carbon monoxide detector on each level of your house. So typically these carbon monoxide detectors are plugged into an outlet near the ground because carbon monoxide is also heavier than air. This would alert you if the level of carbon monoxide in your house starts to go up to get outside, because unfortunately the signs of carbon monoxide poisoning are things like tiredness and fatigue. So often people might go to sleep and then they won't wake up because their brain and body cells were deprived of oxygen for too long. Oxides of sulfur are found when coal, crude oil, or tar are burned, and there's sulfur contained in those natural fossil fuels. So typically, Sulfur is found in coal, and it can be found in natural gas as sour gas. So sour gas needs to have the hydrogen sulfide removed. So you can see if there's been a sour gas processing plant because you'll drive by, and there'll often be fields with large mounds of yellow powder or yellow bricks, and this is the sulfur that was removed from the natural gas. Now, the amount of sulfur dioxide released depends on the sulfur content of coal, which can typically be 0.7 to 2%. But high sulfur coal can contain as much as 6% sulfur by weight. Now, when we talk about natural gas, typically natural gas is considered a cleaner energy source because we can remove that hydrogen sulfide from it. Now, we want to reduce air pollution when possible. So there are some technologies that we use to help do that. So one is catalytic converters, which helps make our vehicles more efficient by capturing the carbon dioxide and methane that's produced and filtering it back into the system. Energy efficient homes will have more insulation. They might have those overhang shades on windows to prevent sun from getting in and heating it up too much. Have insulated materials in the walls and floors, and have newer windows, which again reduce the amount of heat in and heat that gets lost through the glass. And we also want to reduce, reuse, and recycle. So the less products that we consume, the less have to be made, and the less hydrocarbons get used in those combustions. Recycling materials means we can often reuse petroleum and hydrocarbon products instead of mining more. And then reusing what we have, again, reduces the amount that has to be made, which would have to be removed from the earth. Okay. So if we look at a map of air quality for the agricultural areas of Alberta, what we can see here is areas that have high amount of traffic, and a lot of agriculture often have worse air quality because of the increased combustion of both vehicles, farm equipment, and agricultural livestock in Alberta. So flaring occurs when a low quality natural gas is produced, and we're burning it off to produce, and it's burned off to produce sulfur dioxide and sulfur trioxide. So what happens is we add oxygen to hydrogen sulfide to form the products. So when we burn that, we're making a higher quality natural gas, but we are producing sulfur oxides as a product. Whenever any fuel is combusted, nitrogen is present because nitrogen makes up about 78% of the air. When the temperatures reach 650 degrees Celsius, nitrogen activates and forms compounds with oxygen called nitrous oxide and nitrogen dioxide. And they're going to be referred to as NOx compounds because they'll have varying amount of oxygen. So some common sources of nitrogen and oxygen compounds are the combustion of fossil fuels in cars and furnaces, as well as fossil fuel power plants, because the combustion occurs at a very high temperature. So when we're looking at monitoring emissions, we can look at the free troposphere CO2, and we can see where it's denser over certain areas, like the southern European continent, as well as large cities in Hong Kong and the China area, and over the Northeast United States and Atlantic Canada. Now, this is going to be because there's lots of industry in those areas, as well as global air patterns are carrying carbon dioxide to those areas. And we can see the difference between the northern and southern hemisphere because of the increased landmass in the northern hemisphere, which would have increased industry and individuals. So the government creates standards to protect the environment, organisms, and to support the sustainability of resources. So we want to have standards that help prevent destruction of the ecosystem. And they're typically monitored using specialized equipment by an outside group so that there's no interference between the monitoring and industry that is being monitored. So cars are monitored using the MAML labs for their emission standards. Now, there was a scandal a little bit ago where Volkswagen was falsifying their results for their emission standards, and they ended up having to pay reparations to a lot of consumers who had bought vehicles based on false emission standards testing.